All right, my friends, so I'm here to tell you a little bit about physics. So in this video and in most of this class, whenever we talk about physics, we're going to be talking about one-dimensional motion. So we have some kind of axis that we're traveling back and forth on. We have a positive side and a negative side. So just to remind you of a couple things, x of t is a position, a function of terms of time. It is our position at time t. So t is not really shown on the graph, but if you're at some position, like let's say you're at spot 1, 2, 3, that's saying that you're like x is equal to 3 if you're at that point. So that just tells you where you are along the line. The next thing we want to talk about is what happens when you take the derivative of that. Well, that turns out to be our v of t, which we call our velocity. Okay. And remember what a velocity is a velocity is just a rate of change of position. And if that velocity is a positive number, that means that you are moving to the right, or whatever the positive side is. So in this case, the positive side is the right, but it could be like up versus down or something depending on your axis. And if that velocity is negative, that means you're moving in the negative direction. So that would mean you're moving to the left side. Positive velocity means you're moving to the right side. It doesn't matter where you are, it's just telling you what the direction it is. Okay, so that was position, that was velocity. And the next thing we did was talk about one more derivative. So the second derivative position, or the derivative of velocity, was equal to, we call that a of t, and that was our acceleration. Okay. And what acceleration was our change in velocity. So if your acceleration is positive, that means that v prime is positive. That means that my velocity is increasing. It has a positive derivative. So if your acceleration is positive, like your velocity might be going from -3 to -2 to -1 and so on, or your velocity might be going, like 5 and then 6 and then 8 and so on. Either way, it is getting bigger. It's getting more positive. So that's what's going on here. Just to remind you guys briefly about units. When you talk about the units of these, the units of position would be in terms of, say, meters, or of course you could also use like feet or meters or miles, and the time could be like seconds or minutes or hours or days or years or whatever, it doesn't matter. So a position is just in terms of meters. A velocity, a rate of change of position, kind of a dx dt, would be a meters per second, or miles per hour or whatever. An acceleration would be a meters per second squared, because it's derivative velocity with respect to time one more time. So those are the units that we would have for each of those three. Okay, so let's just review. Let's talk about a new idea today, and that is the idea of speed. Speed, when you see this word speed, speed is defined as the absolute value of velocity. Now, because it's an absolute value, that means that it is always going to be greater than or equal to 0, which makes sense, right? At no point do you ever say, like, I'm driving -65 miles an hour. No matter what direction you're going, your speed is always a positive number. Okay. Now, there are some questions that revolve around speed, and we're going to talk about that in just a moment. So, here's a common question. I might ask you, is a particle or an object or whatever, so is an object speeding up or slowing down? And alternatively, what this question is asking is that speed, is that absolute value speed, increasing, or is that speed decreasing? That's what this kind of question is asking. All right, now here are the tips for how you're going to solve this. Basically, what you're going to do is you're going to find the sign, the positive or negative, of the velocity and the acceleration. Because what we're going to say is the object is speeding up. The object is speeding up if your velocity and acceleration have the same sign. So, if your velocity is positive and your acceleration is positive, that means that your velocity is going like, 5, 6, 7, 8. You have a positive velocity and it's increasing. If the object is, I should clarify one more. If your velocity is negative and also decreasing, that would look like your velocity is, -5 and then -7, then -9. Well, regardless, in absolute value, you're getting bigger. So what you're doing is you're checking to make sure that velocity and acceleration have the same sign. And on the other perspective, a particle is slowing down, or an object is slowing down, if your velocity and acceleration have opposite signs. So think of that as like your velocity is moving against your acceleration. Your acceleration is preventing you. So like if you're going forward and you hit the brakes, your velocity is positive, but your speed is decreasing. So the brakes are having a negative acceleration backwards. Basically, they're exerting a negative force backwards on you. So, for example, if your velocity is greater than 0, but your acceleration is less than 0, then that velocity would be going, 60, 50, 30, 10. That's what it looks like. You have a negative acceleration because that velocity is decreasing. So that's how you're thinking about these problems. You're just finding the sign of the velocity and the sign of acceleration and working with that. So let me just give a short example here that should be pretty straightforward. Suppose I tell you the velocity is equal to t squared minus 5. At t equals 2 is the speed of this particle increasing or decreasing? So this is the type of question they'd love to ask you about on the AP test, and just make sure you know about your signs. And again, the way you're going to address this problem is you're going to find the velocity, you're going to find the acceleration, and then ask yourself, are they the same sign? And if they are the same sign, they're working together, the speed would be increasing. If they're opposite signs, they're working in the opposite direction, the speed would be decreasing. So let's see, at t equals 2, my velocity is equal to 2 squared minus 5. That's negative 1, of course. My acceleration, which is v prime, is 2t. So at t equals 2, my a of 2 is just equal to 4. Now, in terms of answering these questions, the actual answers don't matter. And the way you'll write this up is after you've done this work, you'll just say, okay, since my velocity of 2 is negative and my acceleration of 2 is positive, those are opposite signs, so the speed is decreasing. Okay, so that's what they're trying to go for in these problems. Just if it asks if the speed is increasing or decreasing, you're just finding the sign of the velocity acceleration, seeing if they're the same or the opposite. Okay, I'll have some more problem solving tips in the next video. Thanks for watching.